Assalamualaikum warahmatullahi wabarakatuh. Today I'll be explaining about the set that I chose, which is set B, which I need to draw the cell diagram and state the function of salt bridge and do the equation. So, before drawing our cell diagram, we need to know which one is our anode and which one is our cathode. So we can determine our anode and cathode by looking at the cell notation. There's a bit tips to determine which are the anode and the cathode, which is A, B, and C. For A, it stands for anode, and B stands for the bridge, which is the salt bridge, and C stands for cathode. And from here, we can already draw our cell diagram. And for the anode, for this case, for voltaic cell, our anode is negative terminal, and for our cathode is positive terminal. So the direction of our electron will go from anode to cathode. So from here we already complete our cell diagram because we already know our anode and cathode, and we already determine how the electron move, which is anode to cathode.
You may ask, why do we need to have this salt bridge? Well, that's because salt bridge function is to maintain electrical neutrality. Not only that, it used to complete the circuit by allowing ions carrying charge to move from one half cell to another, which is the electron or ions will move from the zinc and goes to the circuit, which is to the Sn, which is the cathode. And so this is my half cell equation, where we start from anode. Zinc will receive electron and return to charge, which is zinc 2 plus equals plus 2 electron, 2e minus. And then for cathode, it will undergo reduction, which is Sn2 plus 2e minus, and since it undergoes reduction, it will lose the electron here and it becomes solid. And so the overall equation will become this: zinc plus Sn2 plus and becomes zinc 2 plus SNS. And for the standard cell potential, which is for the D, we will use this formula, which is E naught cell equal to E naught cathode minus E naught anode. There's also a way, which is we just need to find which one is the highest electronegative, which is for this case the highest electronegative are our cathode, which is Sn, and for anode it's the lowest electronegative, which is zinc. And so we just need to substitute the given inert cell, which is negative 0.14 volt minus negative 0.76 volt, and it will become positive 0.62 volt. And for this case, since it's positive, we could conclude it as a spontaneous reaction. For the spontaneous reaction, it requires a reaction that occurs of its own accord at room condition without requiring energy input for it to occur. This happens because of the positive value that we got from substituting the number into this formula. So we get the spontaneous reaction. Last question, which is E, we need to determine which one is our oxidizing agent and reducing agent, which for this case, our oxidizing agent is Sn2 plus, which is Sn will undergo reducing process. And for our reducing agent, which is zinc, it will undergo oxidation process, which is the electron will add to zinc. And that's all. Thank you.